In this video, we're going to be looking at Le Chatelier's principle, which states that if a system is at equilibrium and is exposed to a change, it's going to shift in a direction that's going to partially oppose that change. So that means if you've got a system that has some products and reactants in it, you can actually manipulate how many products and reactants you actually have by exposing that system to a change. Why do we care about this? Well, it's all to do with money. It's the idea of we can manipulate conditions of a reaction that allows us to reach an equilibrium that maximizes our yield. For example, we've got the Haber process down here, which produces ammonia, which is a really great chemical. This process involves reacting nitrogen and hydrogen to produce ammonia. And if I owned an ammonia factory, what I would want is as much ammonia as possible. So therefore, what I need to do is use Le Chatelier's principle to try and push the equilibrium to the side of my products. And that way, I would maximize yield. There are a number of things we can do to change equilibrium, and I'm going to go through a couple of those in this video. The first and probably most obvious way of producing more products is to add more reactants to our system. By adding more reactants, initially what's going to happen is our reactants are going to increase. That's logic, isn't it? By adding more reactants to a system, we have a sharp increase in reactants. Le Chatelier's principle suggests that we want to partially oppose that change. So what that means was we're going to try and react our reactants together and push the reaction forwards, producing more products. I'm going to go one step further with this particular example and talk about why this happens with reference to collision theory. I've got a lovely graph down here which talks about the rates of the forwards and reverse reaction. Now, if I add more reactants, what that means is the increase in concentration of reactants makes more frequent collisions between our reactant particles. What that does is, as you can see here, it speeds up my forwards reaction. My products do not initially change, so therefore what we have is the forwards reaction being faster than my reverse reaction. So now, because my forwards reaction is favoured, I start to decrease the amount of reactants because they are being used to create products. That means my rate of my forward reaction starts to drop because I have fewer collisions. And then my rate of my backwards reaction starts to increase because I'm getting more frequent collisions of my products because I'm getting more of them. That means that they start to converge again and we reach equilibrium where my rate of my forwards and reverse reactions become equal again. This is the logic behind Le Chatelier's principle. It's all underpinned by collision theory. 2 more videos will follow for temperature and pressure.